So Liam had this question recently in a tweet. He says, question for every non-techie in the space. As someone who is not a developer, how do you personally verify code on-chain or code submitted for upload on governance proposals? Super good question. So I recently did this on Stargaze for CronCat, and so this is good timing to kind of cover how that all works. And also very grateful to see this pass, so thank you to all the voting community here. So if you're not a dev, you have to buckle up like just a little bit. It's not going to be like that bad, but I suspect in coming months and years, people will build tools that'll make this easier. But for now, let's go through like how to verify this kind of contract kind of in the early days of Cosmos. So first off, you're going to want to have a daemon or CLI of this network in question. So Stargaze for us. Let's take Stargaze as an example and see how this is all working here. We can take a look at my terminal window here where I've run a command printing out the version of each of these daemons. At the time of this video, daemons and CLIs are kind of like interchangeable, although I'm seeing some tweets recently suggesting that perhaps we separate them in the future. But for now, let's just call it like a CLI for the rest of this video. So to get the Stargaze CLI, you will go to their repo right here, public awesome Stargaze, and you can actually just follow instructions on the Stargaze documentation site, which is super good. There's one spot where it says version tag, and that is meant to be replaced with the current version of the CLI. I would say as a rule of thumb, the best way that I have found to get that is to go here, look on the right-hand side, here's releases, and then you have 10.0.1, and then I'll just like copy this right here, v10.0.1, and that's what you would replace in that version tag. And also, by the way, pretty much count on Polkachu to always be right about this. So if you want to do a quick way, you can just check polkachu.com. Then just follow the rest of the documentation here, and it will guide you through making sure that you have stars D, which is the CLI, installed correctly. Now that you have the Stargaze CLI, you can run some commands that will interact with the Stargaze blockchain. But first we need to set the configuration so that it's pointing to mainnet, since that's where the governance proposal lives. So to do that, let's just start off by running these commands right here. This will make it so we don't have a million flags in the future. And then it happens to be Stargaze proposal 174 for CronCat that we're going to be looking at. So we're going to use the CLI to basically ask the blockchain, tell me all about prop 174. So you will run stars d query governance proposal 174, and it's going to be kind of a lot. Let's just check this out, just exploring it. A lot of gobbledygook here. So all of this is like, what is going on? This is actually like the smart contract right here, which is why this whole thing is like so long. So it's not that important to look at this, but just realize that like with that command, we can basically see like the bytecode of the binary. So again, we are just verifying that this on-chain smart contract in the governance proposal is going to match when we actually download the source code and we like build it in the way that you're supposed to build it. And then you can look to see, are these the exact same output, basically. We'll be using a couple of utilities. Most of these are already on your computer, likely, except make sure that you explicitly install JQ. You've probably seen this elsewhere if you're a developer. Now let's run a stars D command. Let's go all the way to the bottom. Paste this guy. Stars D query governance proposal 174, and then we're going to say, hey JQ, there's a bunch of JSON here, please look for this one particular thing, base64 decode it, do some compression stuff, and then tell me what the checksum of that is. So it should look exactly like this, and if it doesn't, then kind of stop and ask ChatGPT about the error, and it'll probably tell you what to do. So this like kind of long string of letters and numbers, this is the checksum. So we'll kind of return to this later, but we're going to be looking to see that like, does the source code actually match that checksum? Next, let's get ready to, download the code, and then we're going to need to kind of set up our environment to be able to compile smart contracts. And CosmWasm has great docs, And book.cosmwasm.com has been around for a while and has a lot of really good working material here. I would say even just this like top part is all you really need. Just follow the exact directions in like the first couple paragraphs and you're ready to go. CronCat has taken a lot of inspiration from DAO DAO and really respect that team there. They use this thing called just, and so we do as well. So you will also need to get this utility called just. Okay. Once you get this, then we are going to grab the CronCat code. The CronCat code is here, and typically to clone this, you hit this code button, and then you can just like copy this guy, put git clone in front of it. Your computer almost certainly has git by now, and that's how you get the source code here. So we're going to be building and optimizing the source code. Optimization is something that you always do when making a smart contract that you're going to deploy. You will need Docker for this, D-O-C-K-E-R. This one's pretty easy to Google and install. And just a little brief aside, why do we need this optimization and Docker and stuff? Well, it's kind of like a Rust thing, and this is the same across different ecosystems that use WebAssembly, virtual machine, just like CosmWasm does. Basically, if you don't use Docker, then your smart contract will like contain stuff like users, Mike Purvis / blah, blah. But then someone else might have like users / Reese / whatever. And because those two things are different, then the checksums are not going to be the same. And this is like kind of interesting, kind of not for some people. But you can look into how this is working. And there's some really wise people who have looked a lot into this. So we are going to use Docker, and this is not just like a weird CosmWasm thing. This is what you like have to do. Okay, back at it. So you want to build the project. Some projects are going to have different instructions. Like we use just, some people use like a shell script or something. Just look in the README. For CronCat, it'll be just optimize, and you're going to hit this guy, and this kind of stuff shows that it's working. It shouldn't immediately error or anything. This can take a long time, so I recommend just like going and watching one episode of Arcane and then coming back, and you will see that there are files created in the artifacts directory, and these files will be like the smart contracts that you are essentially like deploying to the blockchain. So we're in our root CW CronCat directory, so we're going to say, give me the SHA-256 sum of a file that's in artifacts / CronCat factory.wasm. And there we go. This is matching. And then we can paste that same command from before just to keep it nice and clean, and boom, take this, paste. So now we have a search up here, and it's showing that both of these are identical. So we do know that this is actually the correct code that is on the governance proposal. Now, arguably, this is a bit technical still. My opinion is that Web3 isn't ready yet, like not even close to being ready. So perhaps it's unsurprising that this sort of verification still has you jumping through kind of technical hoops. But I think it's really good to show this so everyone can understand it, and want to thank Liam for kind of sparking this video. I've also updated the CronCat README with all these details, so you don't have to watch this video again. Anyway, hope that helps. See ya.